Today's journey takes us into a deeper dive into angle and radian measures and some ways that we can represent those and use them in different aspects of the real world. So the first thing we're going to talk about are what's called degree minutes and seconds. So instead of using decimals to represent degree measures like 105.62 degrees, we can use something called minutes and seconds. And those are useful because that can give you an exact measure of that angle without a decimal approximation. So we know that a full circle is 360 degrees. Well, each degree has 60 minutes. Each degree has 60 minutes. So you can think of it, instead of 0.1 degree, it's 1/60th of a degree. So that can get really small. Well, we can also divide each minute into 60 seconds. So we can really get down to the nitty-gritty with these degree measures, because if we're thinking about something like the Earth, the difference between 30 and 31 degrees when you're looking at the Earth, that is a big area, and then we can use minutes and seconds to pinpoint that exact location instead of decimal approximations. So our calculator can convert from degrees, minutes, seconds to degrees, and vice versa. So if we press the second and the apps button, that will get us to this angle menu. The first thing is the degrees. Then that would be for minutes. And then this is if we were doing radians. And then this last one would be to convert to degrees, minutes, seconds. So some symbology here. 1 minute, the symbol for that is like an apostrophe, and the symbol for seconds would be 2 apostrophes, or you could think of it as a quotation mark. And you may say, well, in our angle measure, we don't see this symbol here, the quotation mark. Well, unfortunately, to get that, you have to press alpha and then the plus button. I'm not sure why it's not in this menu, but that's just where it is. So to convert from degrees, minutes, seconds to decimal degrees is actually pretty easy. So we just type in 125, then alpha, apps, degrees, then 32 seconds, so 32, second, apps, and then go down to 32 minutes. And then 51 seconds, 51, and again we're going to press the alpha and the plus button, and that gets us our degree in decimals. So 125.5475 degrees. So we can do the same thing with this angle here, negative 408. So clear that. Negative 408 second apps degrees. Then 16 minutes, so second apps, go down to the second one, and 25 seconds, alpha plus sign, and we get negative 408.2736111. And so this is a repeating decimal, so the minutes and seconds would be more accurate than the decimal approximation. So negative 408.2736 degrees. So that wasn't too bad to convert that way. Converting to degrees, minutes, seconds is even easier with our calculators. So we want to convert negative 115.27 degrees into degrees, minutes, seconds. So negative 115.27, and then we press second apps, and we go down to the fourth option to convert that to degrees, minutes, seconds. So we don't need to put the degree symbol in, we just type in the number and then go down to DMS to get our angle measurement. So that'd be negative 115 degrees, 16 minutes, and 12 seconds. Now there is a way to do it algebraically, but we have the capabilities of our graphing calculators, so we should just utilize those abilities when we can. Yesterday we talked about the definition of a radian, and I said we were going to come back to it today, and what we're going to do is use this formula to solve problems. So remember, S right here is your arc length. R is the radius of the circle. And theta is your angle measure. Your angle measure. And we can use that again to solve problems, but one thing to note about the angle measure that we want to put it in radians, so we may have to convert some things, some angles, like we did yesterday. So here we know theta is 150 degrees, the radius is 2.7. What is S, or the arc length? Well, first thing we need to do is take 150 degrees and multiply it by pi over 180, because that will give us our radian measure. Or you may remember from the unit circle that 150 degrees is 5 pi over 6. But if not, we're able to do that right here. So that's our theta measure. So now we're going to set up our equation. 5 pi over 6 is equal to S over R. We don't know what S is, but we know that R is 2.7. 2.7. So now we're going to multiply both sides by 2.7. Let me write that a little bit neater. So 2.7. And then in the calculator, make sure my calculator is in radian mode. So we're going to do 2.7 times 5 pi over 6. Enter, we get 7.068, and we're told to round to the nearest hundredth, so that's 7.07. So this arc length is 7.07 feet, because our radius was given to us in feet. Right, then letter B, we have that S, the arc length is 600, our angle is 3 pi over 4. We need to find the radius. So this one is a little bit more complicated. So we have the angle, 3 pi over 4 equals 600 over R. So we have to get R by itself. So we can multiply both sides by R. That will give us 3 pi over 4 times R equals 600. Well, to get rid of that 3 pi over 4, we can multiply both sides by the reciprocal, 4 over 3 pi. Now, when we do that, we want to type in the 3 pi in parentheses. So the left side is going to cancel, and we're left with R equals, and then I'm going to do 600 times 4 divided by parentheses 3 pi. If you don't put that in parentheses, what the calculator will do is do 4 divided by 3, and then multiply that answer by pi, but we want to divide by the product of 3 pi. So we get 254.65 centimeters. All right, now on the next page, we have some word problems. So it says find the arc length of a circle with a radius of 9 inches and a central angle of 140. All right, so that means our angle is 140, but we need to convert that into radians. So 140 times pi over 180. That is going to be, if we reduce 140 over 180, that's going to be 7 pi over 9. Divide the top and bottom by 20. And then the R value here is 9. So that is going to be 7 pi over 9 equals S over 9. Multiply both sides by 9. The 9s are actually going to cancel out. So then S is equal to 7 pi. And if we type that into the calculator, we get 21.99. 21.99 inches. Example 5, a central angle theta of a circle with radius of 16 inches subtends an arc of 19.36 inches. Find theta in degrees. Now, if that doesn't make sense to you, we know we're trying to find theta. Okay, so theta equals, and the formula is S over R, and we know R is the radius. So radius of 16. So that means the other number must be S. So if the words didn't make sense, this will help with that. So we type that into our calculator. 19.36 divided by 16, and we get 1.21. Now, 1.21 is in radians, not degrees. So we got to take that 1.21 and times 180 over pi. Because radians can have a decimal instead of a pi component. Like up here, 5 pi over 6 in radians, if we type that in the calculator, that will give us a decimal. All right, so now we can take that 1.21 times 180 divided by pi, and that gets us 69.327 degrees. So we're going to say 69.33 degrees. And then example 6, assume the Earth is a sphere with a radius of 6,378 kilometers. What is the difference in latitude of two cities, which one is 800 kilometers due north of the other? So what this is actually telling us is that is the arc measure, because if we think about the globe, the Earth here, and we have our cities, city 1, city 2, and we know that the radius of the Earth is 6,378 kilometers, and it says the distance between the two cities is 800. So this distance is 800, which is going to be the arc length, that S value. It says, what is the difference in latitude? And we know that latitude and longitude is measured in degrees. So theta is equal to the S value of 800 over the radius. So if we type that into the calculator, 800 divided by 6,378, we get 0.125. radians, and then we take that and multiply that by 180 over pi. So 0.125 times 180 divided by pi. And we get 7.161 degrees. So that is the difference in latitude between the two cities. The last thing we're going to be doing is talking about complementary and supplementary angles. In geometry, you should have all learned that complementary angles that add up to 90 degrees and supplementary angles add up to 180 degrees. Well, the same is true. We could do this with radians as well. 90 degrees in radians is 2 pi. 90 degrees equals pi over 2. And 180 degrees is equal to pi. So to calculate what the supplement or complement would be, we can subtract from 180 or pi for supplement or pi over 2 for complement. So if we have this angle here, 2 pi over 5, and we want to find the complement is going to be pi over 2 minus 2 pi over 5. Because if this were in degrees, like if I said what's the complement of 35 degrees, you would do 90 degrees minus 35 to get your answer. Now, we can't subtract those because they don't have like denominators. So we have to change pi over 2 into 5 pi over 10. And then the 2 pi over 5, we get to change to 4 pi over 10. Now we have like denominators, we can subtract them, and we get pi over 10. So that would be the complement. Then the supplement is going to be a little bit easier because it's just pi minus 2 pi over 5. Yes, the denominators are not the same, but we only need to worry about the first thing, pi, because pi can be written as 5 pi over 5 minus 2 pi over 5, which is going to be 3 pi over 5. So we have our complement and our supplement to 2 pi over 5. All right, so that is it for this lesson. We took some of our previous knowledge and extended it a little bit further, used that new formula, talked about complementary and supplementary angles in terms of pi radians. So thanks for watching. Make sure to like the video and subscribe.